Hey everyone. I'm usually a pretty casual presenter, and so I'll probably speak directly to a lot of folks. It's not as interactive as I like to have it, which is like a lot of questions, but love to, at least I might ask a few questions for people to raise hands and see if they've experienced something. So I will talk a little bit about how to deploy a production-grade application in generative AI, which is a pretty hot topic. I think a lot of people want to know how can this be done. A little bit about myself. I have a lot of company names, but most importantly, I've been working a lot on ML platforms. I've been working on it across 3 companies. Airbnb, I was the product lead for their ML platform, their ML infrastructure, as well as their applied ML team, and started their first labeling team. At Meta, I was a PM manager. I led a team of PMs for their ML infrastructure and an AI platform team. And then now I founded a company with a few folks from Meta, and we're trying to build the next generation of what is a generative AI platform. And so lastmile AI is an AI developer platform for engineering teams. What does that really mean, right? There's a lot of buzzwords there. Everyone's building some type of platform, and so I'll go into that a little bit more. It is developer tools for software engineers, not just ML researchers, to productionize generative AI applications. One of the key things that we've noticed building these platforms over again is we build this so often for ML engineers and researchers. What does the platform look like for developers? We strongly believe that the next generation of people who build these things will be developers. It's not meant to just be for ML engineers and researchers, but broadly applicable for all developers. And for developers, what are their familiar developer tools? This is last mile problem. Oftentimes, people do ask us, like, last mile AI, is that logistics? Is it like Amazon? But essentially, why we call this last mile is because we saw that foundation models were becoming popular. And there was a last mile problem from foundation model to get it into a production application. We view this as a last mile problem, and there's multiple steps to it. For those who are interested, I'll quickly highlight it. Maybe as I go through it, I'll pause, and if people are interested in hearing more, I can elaborate more. If not, I'll just go through it quickly. But it starts with prompt engineering. Everybody's probably done this if they're using GPT-4 or any other model. Then it goes into parameter tuning, your ad hoc and offline evaluation. Currently, ad hoc evaluation is much more popular. What is that? It's kind of when you do the eyeball test. You run it against GPT-4, you're like, does that answer look right or not? Batch evaluation or offline evaluation is you have 1,000, maybe 10,000 different data points. You pass it through. You have some type of evaluation metric. Does it actually pass the test or not? Afterwards, most people figure out that the models are great, but I need to add my own data in. That is data preparation. From there, you can do 2 different styles. One is retrieval augmentation. I think Jerry talked before. He went into a lot about retrieval augmentation. There's also fine-tuning, where you can actually fine-tune your models. Afterwards, model deployment. How do I actually get this into production, integrate it? And then 3 different style approaches. You can have all of them there, which is a rule-based engine. So guardrails. How do I make sure the output that comes out from this model is something that I expect, and how do I prevent that behavior? Second is caching. It's expensive. How many people have run GPT-4 with high traffic? How many people got scared by the bill? It's pretty expensive, right? And so overall caching is one thing that's being more popular. And then audit logs. This is AI. This is ML. It's an ongoing journey. And so you have these audit logs, and you can either review it, manually label it, and put it back into the system to make your models better. So lastmile AI, a little bit about us. We're a developer platform for software engineers to leverage generative AI reliably. We are developer first. This is really, really key for us, which is how do we build tooling and SDKs for software engineers to enable them to integrate generative AI into their production applications. We are enterprise grade. We want to make sure that the biggest hurdle to get into production is it good enough? And is it good enough means you need the enterprise grade features, which is security. How do I make sure that I have source control? All the things that you need to get into production and you feel comfortable bringing it to your business. And then flexible and customizable. I showed, I don't know, was it 12, 13 boxes there? As people are looking through it, they're like, well, I kind of have this solved. Maybe I have some of the observability pieces. I don't need all these pieces together. We understand that, and so we try to make it highly flexible and customizable so you can integrate into your own systems. So a little about last mile AI. mapping out from that developer workflow to what we have. It starts with developers. Then you go into your AI workbooks. It is Jupyter-inspired. It's like a notebook-inspired environment where you can use generative AI. That's where you do your model exploration, your parameter tuning, your prompt engineering. Afterwards, you do your model evaluation. We have something called AI workflows. Batch compute, you're able to run it in batch. You're able to see the results, and you can iterate. Those are both powered by something called AI config. That is the data format that you can use, paired with an SDK to actually deploy this where you need it. For deployment, you can deploy it to wherever you'd like. We're not really opinionated out. We want to make sure that you have the flexibility to deploy this in your own environment, deploy it where you need it. And all of this can be backed by GitHub or any other source code repository. So how does this map to developers? Because we're developers, but in the end, I've brought all the ML pieces into it. It actually goes really well with build, test, and deploy. It just happens that we use all the ML jargon when we talk about it, but it is build, which is you have a notebook-like environment or a code environment, your IDE. Then you have your libraries that you work with it. Test, which is either I run it locally or I run it in some batch compute to test it out. And there's some flavors of the ML kick in. And deploy. Oftentimes, people say inference when you're looking to deploy models. Deploy is have this binary run somewhere. It's a combination of code and data. I want this to run. And so we map this directly to the developer workflow because that's what we're designing it for. So we'll go into each of the stages. We'll start with build with lastmile. AI config. The first thing that we've decided to do was one of the most important things that we feel is how do you actually source control this? When you're putting anything into production, you often want to source control it. And the key thing is there's a lot of data that's being put into these generative AI applications. Part of it is the prompts, the parameters, what model is it going to route to. How do you actually source control all of this reliably and easily have the debuggability and observability? And so we created a library where we've parsed out part of the core ML logic, put that into a config file, JSON object, and we have the library to execute it. And so now prompts act as config files. You can source control this quite easily, whichever you need. This also means you can swap models very easily, which means if you find that GPT-4 is too expensive, you can swap it to GPT 3.5. It means that you can add more logic for routing between models because maybe you use AWS, and AWS has Bedrock and Claude 2. Maybe you want to use the Palm models. Maybe you want to use OpenAI. You can actually swap, mix and match different of the models. So that's where the model agnosticism comes in. Custom middlewares. The generative AI open source community is vibrant. I don't know how many people have been keeping up with all libraries coming out. There are a lot of cool things out there. And having an extensibility to integrate into some of these things that are really powerful, make the flexibility there so you could customize your own solution. And we are developer friendly. We're focused on Node, Python, and we have CLIs regularly available. So with this config file, one of the key things that we realized is you actually need a great kind of IDE to iterate on this. So we support something called AI Workbooks. It's a customized notebook for generative AI. It supports multimodality. You can chain different generative AI applications. You can easily configure model input parameters. You can use a wide selection of different models, GPT-4, DALL-E 3, Palm, and you can share and reuse these workbooks. OK, I think we're going to show the demo. Perfect. Amazing. So I'll talk through it. I'll have to talk quickly because the demo I designed for pauses, but I'm going to try to get through all of it. This is a multi-LLM consistency pause. Amazing. So this is perfect. It's going to pause soon. Amazing. So this is a multi-LLM consistency workbook. What does this actually mean? Part of LLMs, you get inconsistent results. So one of the strategies released in a white paper was a self-consistency workflow where you can actually prompt the single model multiple times, and you aggregate the results in quorum and say, what's the best result? This is an example where we actually did it with 3 different models. We ran it against GPT-4, GPT 3.5, as well as the Palm models to get 3 different rationale and reasoning results. And then we aggregated together to an evaluator and a quorum decider. And so the question in the paper, in the published white paper, was deciding the age. And it's a little bit of a tricky question. So the question was, you're 6 years old, and then your sister's half your age, which means that she's 3 years old, you're 70 now, what's her age, right? And so it's a little bit tricky because generally LLMs at the beginning were like, well, it's half, and so I'm going to divide by 2. Age doesn't work like that. If you're 3 years difference, then it'll continue to be like that. So this is one of the examples that we've built. If we roll it, amazing. And so we run it against 3 different models. For this ChatGPT, I choose GPT 3.5, wide selection of different models, DALL-E 3, Stable Diffusion. It is multimodal. Then I run it against Palm. I do few-shot prompting, so I put some examples to try to infuse the logic into it. And then the last part is the majority evaluator, where I can run it against the 3 different models, and I could say which is the consistent answer across it. So it's implementing a little bit what's in that paper. I download the AI config file, which is the logic backing it. In this IPython notebook in Colab, I'm able to run the SDK. And from the SDK, I read the JSON file. And that JSON file is able to execute that exact same logic. And so now you're in the developer flow, where from the data that provides it and models everything behind it, you can actually execute it. I click into the JSON object. You can see it specifies GPT-4 3.5 as well as the Palm models. It has the parameters, which are passed through. And it has the logic that's encoded in. We have handlebar syntax for parameters, and so you can actually do more complex logic in between. We are multimodal, and so one thing I wanted to show in the workbook was Stable Diffusion 1.5. I did not record it with DALL-E 3. We do support DALL-E 3. But for this example, you can see we create some images with Stable Diffusion 1.5 for like a Western cowboy style-esque system. Amazing. There we go. So multimodal AI config backs it. You can actually integrate it into your production applications using the SDK. But would you feel comfortable doing this? Probably not. So that's when you get to testing with lastmile AI. How do you test these? You can do your ad hoc test where you run it once. Clearly, within that IDE, you can execute it once. You can eyeball test, is this the right answer? How do you actually run it in batch? We support something called AI workflows. AI workflows, you can actually test and evaluate your generative AI application at scale, which means you can send in multiple rows of results, pass it in, execute it, and get the results back. And you can evaluate whether your generative AI application works for your use case or not. We provide that to be scheduled. You can scale it for your organizations, and we do management capabilities on top, so you can pause, execute, or kill different workflow executions. This is another demo video, perfect. So pause. Amazing, nice. The last cell that I've introduced at the end was you are GPT-4. I want you to respond with yes or no, and does the proposed answer kind of match the actual answer? So it's the exact same workbook that you've seen below, but I've added one extra step, which was I want you to compare the ground truth set that I'm about to pass in with the data that's being already generated, and I want you to do just a yes or no response on whether it's correct or incorrect. Roll. Amazing. OK. And then pause. Perfect. And so 2 different styles. One is pass in JSON, and then you can also pass in a CSV. And then from here, you can actually limit to, we have a limit right now because it's in beta, 1,000 rows. But you can actually run against any number of rows that you'd like. Roll. Amazing. And you can copy over the headers. Oh, pause. So it might be hard to see. But in this demo, we only do it with 3 rows. We did decide to get a couple of middle school tricky math questions, which is kind of what the original paper had. And so the second question we added was, I'm an odd number. If you subtract 10 from me, you get 15. What number am I? And the second one is, a family has 5 sons. Each of them has a sister. How many kids does a family have in total? For us, it should be trivial, which is like, it doesn't mean that each son has an equivalent daughter. It means that one sister leads to all of the sons. You know, it's a little bit tricky. It's something fun to test against generative AI models and kind of evaluate how it works across the board. And so one thing you can see is column C within this Google Sheet, I added the ground truth. The first one is 67 years old. The second one is 25. And the third is 6 kids. It can be strings, which means I can actually pass it anything because I'm asking I'm asking a model to actually evaluate whether it's correct or not. If I had a specific function that I want to do, which that does exist, where I want to compare the exact value, it has to be numerical with what's returned, then you could specify that yourself. Roll. Amazing. So I kicked off a batch workflow run, and that workflow run will kick off an individual run for each one of these. And so there's 3 different runs, each for the different rows. I'm just refreshing here to see when it gets kicked off. It only takes a few seconds to actually run. I think it took about 14 seconds for each. There we go. I go into the first one to see what the results are. Oh, pause. Amazing. So ChatGPT even responded with a little bit of an elaborate answer, which was, the question is a bit tricky because it seems like there should be 6 children in total, the 5 sons and their sister. However, the statement says that each of them has a sister. This implies that there's only 1 sister, not 5. Therefore, the family has a total of 6 children. And so it's a verbose response, mostly in string. You can actually use this, and it actually has some of the elaboration of why it decided this reasoning. Palm also has the answer 6. And so I'm able to run this across all of the different rows that are specified, all the riddles, and then I could evaluate the results. Roll. Amazing. And then you can actually see that most of the results have, I think they all had yes, which is the correct answer. And now I can do this at scale, which means if I have a ground truth set and I have different test cases to run against, I can run it all. These are the parameters where I can actually inspect what was passed in for this specific run and see what the results are. Amazing. Last but not least, the key thing is deploy with lastmile AI. I mentioned before that you could deploy it wherever you want. And that's a key thing for us, which is overall, we understand that there's a diverse amount of use cases, and we want to make sure that you can use this and where you need it to be. We've open sourced the AI config library so that you can run this where you'd like to. For the AI workbooks, you've seen the hosted version, but we actually are going to release a local version as well so that you can run this yourself. And then AI workflows, if you're looking to run this on your own batch compute, you can do that as well. We really want to make sure that we enable developers so that they can use generative AI. There's a lot of systems out there that are focused on how do you get the ML workflows to incorporate generative AI. We want to go from the other side. We want to really focus on developers, and from developers, how do they get into generative AI? And that means looking at their workflows carefully from build, test, to deploy. What tools are they currently using? Are they using VS Code? Are they using GitHub to source control their things? What's their CI/CD environment? And how do you incorporate that into the general generative AI workflow? And so for the inference path, you can go with Vertex AI. You can do SageMaker. You could do local execution. You can use Streamlit. You can kind of go wherever you want with it. We provide the library for you.